Where is Mr. Sam's? I wonder where Mr. Sam's is. There he is. He's there in the back of the room. How did he get from there to there? Must have to do with quantum mechanics. How did he get to there? He's jumping. Quantum leaping. Ah! How did he get there? He's scary face too. Mr. Sams, how did you move around the room like that?
Quantum mechanics.
Quantum what?
Quantum mechanics.
What do you mean?
Well, it's a model that we use to figure out where electrons are, or should be, or could be, I guess, probability speaking, in electrons.
So that's what we're talking about today. Quantum mechanical model of the atom. That is the topic for today. So let's have at it. All right. All right. Quantum mechanical model. It was developed by a German dude.
Oh yeah.
This guy right here. You know his name?
I'm gonna guess that's Schrodinger.
Yeah.
Schrodinger.
Yeah.
Based on the little URL that's underneath this.
Yeah,
picture.
that probably helps you there.
Yeah.
So it comes from the mathematical solutions to the Schrodinger equation. Now that's like a complex equation.
Yeah, it's pretty crazy.
It's really crazy. So
I don't know how to do it.
I don't either. So the good news is that you guys don't have to learn the quantum mechanical equation or Schrodinger's equation because, but we're just going to tell you what the results of the equation are.
Exactly. Conceptual understanding of some really crazy hairy math.
So it turns out that when we're talking about where electrons are, guys, is electrons are sort of, well, they move around, but they don't move. It's kind of this weird thing, kind of like Mr. Sams. He was here and there, but he wasn't in between. He jumped.
Yeah, I was in one place, and I was in another place, but I was not in between. So electrons, when we talk about them in an atom, is they can be in certain areas and other certain areas, but not in between those areas. And they don't even transfer from one to another. They don't travel between their are at one place or are at another place. So it's kind of weird. It's unlike anything else that you've ever really thought of because you live in a Newtonian world. This is like a quantum world. And so it's just kind of weird. And if you take physics, you're going to learn a lot more detail about this. We're going to give this a real kind of
brief overview.
Yeah.
So it's a region where an electron is most likely to be found.
Right. This is all based on probability. So we're going to show you pictures of shapes of spheres and dumbbell shapes and stuff. And don't get too hung up on them being exactly that shape because that shape represents where the electron is 90% of the time. It's called a probability distribution.
Yes. Oh, distribution. Yes, that's a good word. Okay. So in the quantum mechanical model, what we've got is these things called atomic orbitals.
Yeah.
Now, the thing I don't like about the word orbital is that they don't orbit.
They don't orbit, no.
People, kind of a bad name for it, actually.
Yeah,
they say that they go...
Well, historically speaking, a guy named Niels Bohr came up with this idea of orbitals where the electrons, he thought the electrons moved around the nucleus like planets move around the sun.
Right.
That's where the idea of orbitals came, but later on with the quantum mechanical
model. Here's like a
stuff.
sphere where the electrons, this would consist of actually two electrons. It's kind of a weird thing to think of that the sphere is two electrons, but yet the electrons are like tiny little dots. So it's actually a probability. If you look over on this picture right here, then the electron could be sort of anywhere where those dots are. So probability
90% of the time.
90% of the time.
Yeah.
And so there's different kinds of orbitals. The first one is called an s orbital, and the s stands for spherical. It kind of looks like a sphere. Duh, right? And then the second model is called the p orbitals, and they have a slight dumbbell shape. If you notice here, this is the shape right here, and so you can kind of see the shape of them right here, and it's p shape. So this would also consist of two electrons, where there's a 90% probability of it being anywhere.
Notice they're not in that little middle section where the lobes are.
Yeah, they do not exist. So it's kind of weird that they're two electrons, and they could be sort of here or here. But how do they get from here to here?
They just do.
They just do. Just kind of like you just appeared and disappeared. Teacher. Yeah. And the third one type is called the d orbitals. There are 5 different shapes.
I like the donut one myself.
The donut one is cool. Donuts. You eat too many donuts, Mr.
But they're
Sams.
so good.
I know. And you can see how they kind of all smush together into this kind of funny looking shape.
Yep. So guys, what your takeaway from this is you need to know a couple things. One, that the electrons are in certain areas and we get their shape based on where they are according to probabilities, to some crazy math that you don't have to understand. And you need to know that S's are spherical, P's are dumbbell shaped, and that D's are kind of clover shaped, and then one of them has a donut.
And there's actually, I think I put the F. No,
F's are wacky.
Yeah, I didn't put those on there. There's also F orbitals. We won't worry about that.
Yeah.
Now let's do a little clip where we talk about kind of where the electrons, how they kind of fit together.
Okay.
So let's take a field trip to South Dakota. All right. So where are the electrons in atoms? Well, remember they exist in orbitals or shells. And I want you to envision the shells like this tiny little sphere, this metal sphere right here. The electrons exist on the outside of that sphere. They sort of are the outside of that sphere, actually. But they're in concentric spheres. So this would be like the 1s level. And if I go bigger, and I want you to take another size ball, and if we put it inside here, envision this sphere inside of this ball, and then we have now the 2s orbital. Okay, and so now that consists of a maximum of 2 electrons, and so that is the outside, not the whole ball, but the entire outside. So envision this embedded in here, and then we can get bigger if we went to the 3s orbital. And now envision the metal ball inside the, I don't know if that's a racquetball size thing, inside the softball, and then you can get bigger yet. You can put it inside of the basketball. So envision them sort of inside of each other, inside of each other, inside of each other. And that gives you an idea of where the electrons are in an atom. So, Mr. Sams, did that make sense?
Yeah. So the higher the energy level, the bigger the area that electron can be, or the further away it is from the nucleus, basically, right?
So you kind of can envision the electrons existing in these circles, or spheres, really, and they can be anywhere in the space at a time. They can jump between levels. Now, here's kind of a really good series of pictures to help you understand this. In the quantum mechanical model, I want you to think of right here this red sphere as what's called the 1s level, level 1, and it's a sphere. And you can have 2 electrons. This would be represented by the tiny little metal sphere that I had in the video clip.
Okay.
All right, and if we move up, so this is what the atom looks like, or where the electrons are. If we sort of jump, you can kind of see here in the center of the picture, we have the a 1s here in the middle.
So that's like the little silver sphere you had.
Yeah, a little silver sphere. Now we have an orange sphere, or whatever color you want to call that.
Okay, and that's like the ball that you have with the smiley face on it.
Right.
Okay.
Right, the 2s orbital, right? And
so
then
higher energy level, further away from the nucleus.
it's same shape though, the 2s level. Now the thing I wasn't able to show with the different balls is that I have right here the 2p. The 2p now is just sort of these green dumbbell shapes. If you look at these, right? So you can still see the red guy, and now you can see the orange guy, and now we are kind of zooming out, kind of, if you will. We can see the electrons that would have the shape of the dumbbell, and then we can keep going out. And now we have the next level.
So that'd be like the 3s, because I see the 1s and the 2s and the 2p in there.
Yeah, and this is the 3s orbital.
Mr.
Right
Bergman
here.
just broke the pen. I'm going to fix it while he keeps talking.
So here in this picture, we've got the little red ball right here, right? That's the
1s.
1s here. And here's the 2s.
And then the big outer one would be the
2p here. And then there's the 3s is the big green ball.
Okay, so bigger energy level is just, again, getting further and further from the nucleus. So this would be like the softball you had, the 3s.
Yeah. Mm-hmm.
Okay. And all the lower ones are kind of inside of it, if you will.
Right. And this next one, we can kind of see this. And this notation we'll talk about in our next podcast. But now we move up to 3p. 3p are the green dumbbell shapes, as you can see there. And then if we continue on, we can then get to it's called the 4s. That doesn't show up here.
See it there.
4s is the blue ball, but you can kind of see there's the little red ball,
Yep.
and then it was a green ball, and then we got the P shape, and then the other P
So
shape.
this would be like the basketball.
The
all
basketball.
All the smaller ones,
Exactly.
closer to the nucleus than that one.
And so, and then we get
it's
crazy.
going and
This is
going.
actually where we get to the this is 4s, and then 3d, and the 3d are these sort of blue, greenish. What do I call them? Green, I guess. I don't know. They're the ones that we saw with the D level as well. And then we can get crazy, and then we get the 4p, which are the blues, and somewhere in the middle of that is that tiny little red ball. This is where we get more and more and more and more electrons. Here we would have a very large atom with many, many electrons when we had a situation like this. And I think there's one more picture. So actually, we have this. This was I drew these. They weren't professionally drawn. I bet you could tell.
You're amazing.
1s, 2s, oh amazing. 2p. This is not done two-dimensionally. 3s, 3p. Wonderful drawings, Mr. Bergman. 4s, etc.
amazing.
So yeah, that's kind of where the electrons are in an atom, in the quantum mechanical model of the atom.
Okay, so bigger number, further from the nucleus on average.
Yeah.
S's are spherical, P's are dumbbell shaped, D's look like clovers, and there's the donut one, and that's about it.
That's it.
Okay.
I think we're good. All right. See you guys in class. Bye.